Okay guys, welcome. I thought I would mix things up a little bit here and create a video presentation of the notes that you can kind of work through at your own pace. We are starting and we're going to go over lesson 1.5 today, exploring angle pairs. This will coincide with your guided notes, and if at any point in time that you need to stop and pause because I'm kind of writing too fast, go ahead and do that. Alright, so 4 vocabulary words that we're going to define and give an example for right now are adjacent angles, vertical angles, complementary angles, and supplementary angles. So, an adjacent angle, or adjacent angles, I'm sorry. The definition: two coplanar angles with a common side, a common, excuse the writing, vertex, and no common interior points. Okay, so it's a lot of mumbo jumbo. Let's put an example down and you'll see that really it's quite simple to understand. So here we have an example of two adjacent angles. When you hear the word adjacent, you want to think of angles, or well, not angles, but when you hear the word adjacent in general, you think of two things that are next to each other. Okay, so we see that angle 1 is next to angle 2. All right, so adjacent angles there. Next vocabulary word: vertical angles. Very simply, these are angles that are formed when two lines make an X. Alright, so make an X. Alright, angle 1 and angle 2 are vertical. See how they're looking kind of right at each other? And since they're vertical, we can say that they are congruent to each other. Alright, also we can name this angle 3 and angle 4, and we can say angle 3 and angle 4 are vertical, and angle 3 is congruent to angle 4. Alright? Complementary angles is next. Those are two angles whose measures have a sum of 90 degrees. They may or may not be adjacent. Okay, so an example of complementary angles: we have a right angle. Draw a ray. Let's label this angle 1 and angle 2. So angle 1 and angle 2 are complementary, because you see that if we add them together, they make up that right angle, which is 90 degrees. Now they don't these are adjacent here. It doesn't always have to be like that. For instance, name this angle A. Let's say this is 43 degrees. Alright, let's name over here, let's say this is B. This is 47 degrees. So angle A and angle B are complementary because 43 and 47 is 90. So their sum is 90 degrees. And finally, we have supplementary angles. These are two angles whose measures have a sum of 180 degrees. Alright, again, may or may not be supplementary. I'm sorry, not supplementary. May or may not be adjacent angles. So, supplementary angles, gotta watch right in the middle of this thing. So we have a line. We know that that line is 180 degrees. So we'll name this angle 3 and this angle 4. And together, do you see how if we add this to this, it gives us 180? So angle 3 and angle 4 are supplementary. So these are supplementary adjacent. This is 150 degrees, and this is 30. These are also supplementary. But they're not adjacent. So as long as the sum of the angles is 180, alright, we say that they are supplementary. And it's just the two angles. Can't have 3 or 4, just 2. Same thing with complementary angles. Alright, I'm going to pause the video right now and load up a couple of slides. So at this point, you should be at problem 1. And what I want you to do here is to press pause when I'm finished here and answer A, B, and C, and then sign into Socrative.com. Remember the password Barber44, and go ahead and submit your answers. When you're finished, obviously hit end pause and continue on. Okay, the next part in this lesson is determining what you can assume and what you cannot assume from an unmarked diagram. So what you can assume that angles are adjacent, you can assume that angles are adjacent and supplementary, and you can assume that if angles look vertical, they are. What you cannot assume is that angle or segments are congruent. You can't assume an angle is a right angle, and you cannot assume angles are complementary. Okay, problem 2. What can you conclude from the information in the diagram? Alright, well, the first thing that should jump out to you is that angle 1 is congruent to angle 2, because we notice the red arcs, the one single arc for each of those means that they're congruent to each other. Alright, the second thing that we can conclude is angle 3 is congruent to angle 5, and we can say that because they are vertical angles, and we know vertical angles are congruent. So we have the X there. 3 and 5 are kind of looking at each other, so they're going to be congruent. They're vertical angles. Alright, what else? We can say that angle 1 and angle 2, angle 2 and angle 3, angle 3 and angle 4, angle 4 and angle 5, and angle 5 and angle 1 are adjacent angles. Sorry, looks like adjacent, but that is adjacent angles. All right, they're right next to each other. All right, and then finally, we can also say that angle 3 and angle 4, as well as angle 4 and angle 5, are adjacent supplementary angles. Alright, and so what does this mean? Well, by definition of supplementary angles, angle 3 plus angle 4 equals 180 degrees. And angle 4 plus angle 5 equals 180 degrees. Alright, so flip the page or look over to the next slide, and that is what's next. Alright, we now begin talking about linear pairs. This is going to be a quick slide, term that you should all be familiar with. I'm sure you are. A linear pair, what is it? It's a pair of adjacent angles whose non-common sides are opposite rays. And then the angles of a linear pair form a straight angle. So there's one, there's the other adjacent angle. So together they form this straight angle. So from that we have postulate 1-9, the linear pair postulate. So if two angles form a linear pair, then they are supplementary. Okay, problem 3, finding missing angle measures. Angle KPL and angle JPL are a linear pair. Alright, so that is important to know. The measure of angle KPL equals 2x plus 24, and the measure of angle JPL equals 4x plus 36. What are the measures of angle KPL and angle JPL? Alright. So I'm just going to outline these. Together, these two angles equal 180 degrees because they form a linear pair. So in order to help us find what the angles are, we're going to set up an equation. So we can say that angle KPL plus angle LPJ, they form a linear pair, so they equal 180. And now we just plug in each of these expressions into what the angle, what angle they represent. So we're going to have 2x plus 24 plus 4x plus 36 equals 180. Combined like terms, we have 6x plus 60 equaling 180. So we have 6x equaling 120. Subtract 60 from both sides. And so x is going to equal 20. So that's step 1, define what x is. Step 2 now is to plug x into the expression for what each of those angles is. So angle KPL is going to equal 2 times 20, which is 40, plus 24. So that's going to be 64 degrees measure. And the measure of angle LPJ is 4 times 20, which is 80, plus 36. So it's going to give us an 116 degree angle there. We add those up, we see that they sum to 180 degrees. Okay, 2 more slides. we're going to talk about an angle bisector real quick here. If you remember, we were talking about segment bisectors the other day, and the segment bisect, when you hear the word bisect, it means to split something in half. So an angle bisector is a ray that divides an angle into two congruent angles. So in this diagram here, we are told that ray AY is an angle bisector of angle XAZ. So it divides that angle in half, and we can tell that by the congruent marks there. So what can we say? We can say that angle XAY is congruent to angle YAZ. Yaz. Okay, and then last but not least, problem 4, multiple choice question. It says that ray AC bisects angle DAB. If the measure of angle DAC equals 58, what is the measure of DAB? Alright, so this is a pretty straightforward problem here. Here is ray AC. It bisects DAB. So if this is 58 here, then this also has to be 58. Alright, so what is DAB, the big angle? What are you going to do? Well, you're going to take 58 and add 58 and get 116. So fill in D over here. Alright, hope you enjoyed the lesson. Interested in getting some of your guys' feedback.